Welcome back, students. Our topic to discuss today, occurrence of metals. This is included in your chapter number 3 of your general science, metals and non-metals. In last two classes of this third chapter, metals and non-metals, we have learned the physical properties of metals and non-metals, then chemical properties of metals and non-metals, and then reactions of metals with different reagents like oxygen, water, acids, bases, and non-metals. We have learned how metals and non-metals combine together to form the ionic compounds, then chemical properties of ionic compounds, and so many things. So today is our last part of this lesson, and we are discussing today occurrence of metals. So the first question that comes to our mind is, where do the metals really exist and how? Metals exist in the nature, that is on the earth crust as well as below the earth crust. But the existence of metal depends on its reactivity. So first of all, we will come to know that the most unactive metals, means the metals which are, you can say, noble, like gold, silver, and platinum. Basically, they are found in free state in the nature. Then most of the metals, they exist in the nature in the form of their compounds. Why? Because these metals are active, they react with various chemicals, oxygen, and other elements that is present, and they form different compounds like oxides, carbonates, sulfides, etc. And they are found in the different form of compounds under the earth crust or above the earth crust, and this type of compounds we call them as either minerals and ores. So what are minerals? So minerals are those natural substances where metals are found. Metals are found not in free state, but basically in the different form of compounds. On the other hand, ores are those minerals from which metals can be extracted easily, economically, and conveniently. So frankly speaking, therefore, there is not much difference between minerals and ores. Minerals and ores both are the natural compounds which contains metals, but ores are those minerals from which metals are extracted easily. So all ores are therefore minerals, but all minerals are not considered as ores. Now, ores contains various impurities. Therefore, in the metallurgical process, before extracting a metals from the ores, those impurities are to be removed. Those impurities are called as gangue. So, check the spelling of gangue, Gangue, should be pronounced as gangue. So, gangues are those impurities which are present in an ore and which are to be removed at the time of metallurgical process. Now the question is, what is metallurgy? Metallurgy involves all those chemical processes by adopting which metals can be extracted from their ores in a scientific way. Now, activity series of metal. This is very important. As we have already mentioned, that metals exist in the nature in different forms. Some metals exist in the free state, while some others exist in the form of their compounds. It is because of the reactivity of the metals. Now, metals can be arranged on the basis of their chemical reactivity in a descending order. That is to say, from the most reactive metals, gradually we will arrange the less reactive metals in a systematic way. You can see in the chart on the left hand side, you can see the metals are arranged from top to bottom according to their decreasing reactivity. So this is important, and you will have to remember this activity series which is available in your science book. Now, depending on the chemical reactivity, metals can be divided into 4 categories. These 4 categories are: number 1, the highly reactive metals, or highly, that is, active metals. These are the metals which can be extracted from their ores only by a process called as electrolysis, like sodium metal, potassium metal, etc. are some examples which are highly reactive, and so they are extracted only by electrolysis method. We will try to understand what is that electrolysis method in distillation. Second category of metal comes, you can see on the slide, that is moderately active metals. These metals are reactive, but its reactivity is less than the compared to those metals I have already mentioned, like sodium, potassium, calcium, etc. So these metals include zinc, iron, etc. These types of metals are a bit less active, so they are called as moderately active metals, and they can be extracted from their ores by following certain processes, and especially those processes include carbon reduction process. Then comes to the lowly active metals. Lowly active metals means their reactivity is very less. You can see in the book, and you can see even on the slide, those metals will come under the category like copper, mercury, etc. are some metals which are very less in their reactivity, and they are accordingly placed in the third group called as lowly active metals, and they can be reduced simple process by simple heating process, that is reduction by heating. And the fourth, the last but not the least, is the noble metal or the non-reactive metals. So these metals need not any extraction, because these metals are found in the free state in the nature because of their low reactivity. They never react with any reagents, and an example of those noble metals like gold, silver and platinum. Now let's see the extraction of metals which are placed in the high of the reactivity series, that is at the top of the reactivity series. So we can see here the metals which are high up in the reactivity series, they are so reactive that it is not easy to extract them from their metals, and we have to adopt a process called electrolysis. Examples of those metals which are found in this category like sodium, potassium, calcium, aluminum, etc. Sodium, then you can see the magnesium, etc. are always obtained by electrolysis method. But we will discuss according to our syllabus sodium. How is sodium metal extracted from its ore? Sodium metal is extracted from sodium chloride, that is common salt, table salt. We use frequently, this salt is a very common chemical that we use in our kitchen. But from this common salt, we extract this valuable and very reactive metal sodium by a process called electrolysis. How we do this? To understand this, we will have to go in details about the electrolysis method. What actually we do on electrolysis of molten sodium chloride? Sodium chloride breaks down into sodium positive ion, cations, and chloride negative ions or the anions. And then by using those electrodes, that is cathodes and anodes, sodium can be extracted at the cathode, because cathode is negatively charged. So sodium positive ion will get reduced in the cathode by accepting electrons, and chlorine, which are the positive negatively charged ions formed, they will be attracted towards the anode, and there it will get released in the form of chlorine gas. We can understand this by the picture given at the end of this slide, anode reaction and cathode reaction. Very clearly you can see here, I can point out this is the anode reaction. You can see here in the anode, because it is positively charged, the chlorine negative ions will reach there, and these negative ions of chlorine in the anode will donate electrons, and thereby it will get converted to chlorine gas. Similarly, you can see the cathode, being it is negatively charged, the positive ion sodium positive ion, they will be attracted, and then sodium positive ion will accept electron in the cathode, means it will undergo reduction and will form sodium metal. This is how sodium metal is extracted by electrolysis of molten sodium chloride. But how it is done? It is always done by a technique, and this technique, you can see, you have to use a container. This is the container, you can see that in the diagram. In the container, this is the opening through which we will enter or we will put sodium chloride. So it is sodium chloride inlet. In the container, you can see this is you can see special shaped, and this is the shape where you can see this one is called as the carbon anode. It is made up of carbon. And surrounding the carbon anode on this side, you can say this is the cathode. So you can see this sodium chloride is put inside, molten sodium chloride is put inside, and electric current is connected to anode and cathode. And as a result, what will happen? The chlorine gas will be produced or liberated here in this particular end, which is called as anode, carbon anode, and the gas will be liberated through this outlet. And the molten sodium, the sodium metal, will remain inside the container, and this will come out to this particular container, and from where you can get the sodium metal separated from this container. This is how sodium chloride can be extracted. Sodium can be extracted from sodium chloride. So this was an example how highly reactive metals like sodium can be extracted from its ore, sodium chloride, by electrolysis method. Coming back to second one, the extraction of metals which are placed in the middle of the activity series, which are medium in their reactivity. The metals which are placed in the middle of the reactivity series are like iron, lead, zinc, etc. And these are usually present in the form of either carbonate or in the form of sulfide under the earth crust. For example, if it is zinc metal we are talking about, then zinc metal is available under the earth crust in the form of carbonate, that is zinc carbonate, or in the form of sulfide like zinc sulfide. It may be apart from zinc, it may be suppose iron, then it is present in the form of hematite, it is in the form of oxide, or iron sulfate, ferrous sulfate. In the different forms, these metals are available in the form of ore. Now, the sulfide ores or carbonate ores, not easy to get the particular metal from this form, that is from the carbonate or sulfide ore. Therefore, it is very much necessary to convert those sulfide ore or carbonate ore into their oxide form. It is necessary. It is a very important step, remember. Why it is, remember, I again repeat, it is not easy to extract those metals like iron and zinc from their sulfide ore or from their carbonate ore. So what therefore scientists to do, they convert those sulfide or carbonate ores to oxides, metallic oxides. Suppose if it was zinc sulfide, it will be converted to zinc oxide. If it was zinc carbonate, it will be converted to zinc oxide. So this will definitely help the extraction process easy, and this process we call as roasting. One process is called as roasting, and another process we use here is calcination. So what is roasting? So roasting is, you see, let us see, it is given here, you can see very clearly, the sulfide ores, they are, what is done? First, these sulfide ores are converted into oxide by heating them in presence of air, excessive supply of air, and we call this process as roasting. So it is given here, this process is called as roasting. So how is roasting done? You can see an example of roasting when zinc sulfide is converted to zinc oxide by heating in presence of air. You can see the chemical reaction given at the bottom. Zinc sulfide, ZNS, is heated in presence of oxygen, CO2, And if you heat it, then what will happen? Zinc sulfide, ZnS, will get converted to ZnO, zinc oxide, and apart from that, carbon dioxide gas is produced. This reaction clearly help you to understand how zinc sulfide, means a sulfide ore of zinc, is converted to zinc oxide, means to an oxide ore. So this chemical process is called as roasting. Similar to the roasting, there is another process. If it is not a sulfide ore, but if it is a carbonate ore, then these carbonate ores are never roasted, but they are calcinated, and this process is called as calcination. So what is calcination? In this process of calcination also, we will heat the ore, carbonate ore, but difference is in absence of air. Roasting was done in presence of air, but calcination is done in absence of air. So in absence of air, if we heat the carbonate ore, it will, or they will get easily converted to oxide. You can see the examples like zinc carbonate, calamine. This is a carbonate ore of zinc, and if you heat it strongly, it will get converted to ZnO, zinc oxide, plus carbon dioxide. Another example is given for calcium carbonate, limestone. This is the ore of calcium, and if you heat calcium carbonate, CaCO3, strongly in absence of air, it will get converted to calcium oxide and carbon dioxide. And this is how scientists actually convert those sulfide and carbonate ores to oxide form. And once they are converted, then the zinc oxide or calcium oxide, then they are mixed with coke. Coke means a pure form of carbon, and ground into fine particles, and then it is heated at a temperature of 1673 Kelvin inside a fire clay. And then what will happen? Zinc oxide will be reduced by carbon, that is the coke you have added. You can understand it, whatever I have said here in this part, you can understand it by looking at this chemical reaction given below. What can you see? The zinc oxide that you have obtained after calcination or roasting is now added to carbon, that is coke. And if you heat it, what will happen? The coke, that is carbon, will take the oxygen away from zinc oxide, means zinc oxide will get reduced to zinc, and coke itself will get oxidized. This is how zinc metal can be extracted. Similar is also seen in case of iron. Means in iron or in case of zinc, the extraction process at the end is always done with the help of carbon, and so we call this is carbon reduction process. Now let's move on to the next slide. We will see here basically the difference between calcination and roasting. This slide is very important, my dear students. Please note it down. Whatever is given as the difference between calcination and roasting, you must remember all these things, so please write it down. So let us move on to the next slide, the extraction of metals which are lowly active. The metals which are extremely low reactivity, they have low reactivity. The examples of such metals which are very lowly active may be copper or maybe mercury, etc. are some examples. So if it is copper or if it is mercury, both are extracted from their ores like copper pyrites or maybe from, that is cinnabar, that is mercuric sulfide. So copper and mercury both exist in the nature in their sulfide form. You can see here the example. This was the chemical reaction Cu2S, copper sulfide. Similarly, mercuric sulfide, HgS. Both these metals like copper and mercury are present in their form of sulfide. So definitely these metal ores are to be roasted, and if you roasted them, what will happen? Copper oxide will be formed. And you can see this again, this is copper sulfide. It is heated in presence of oxygen, and as a result it is changing to copper oxide and sulfur dioxide gas is produced. So this is roasting. So after roasting, what will happen? This copper oxide that is seen here, copper oxide, by heating you can release the oxygen from copper, and as a result you will get copper metal. Or we can find another example. This is similarly cinnabar, that is HgS, mercuric sulfide. It is the ore of mercury, and when it is heated in air, it is heated in air, means roasting is done, then mercuric oxide will be produced. You can see the chemical reaction. This is AgS cinnabar. It is heated in presence of oxygen. As a result, mercuric oxide is produced along with sulfur dioxide gas. So this step is here mentioned as roasting. And after roasting, whatever the mercuric oxide is formed, you can see this is the mercuric oxide, and this mercuric oxide, when is heated, simply it will produce mercury and oxygen gas. So this is how copper metal or mercury can be extracted from their ores by heating. So we have seen so far the most active metals are reduced by electrolysis method. Moderately active metals are reduced by heating with coke, means carbon, after that is performing roasting and calcination. And lowly active metals like copper or mercury are extracted from their ores by heating. Simple heating, no need to add carbon or coke in this time, because they are lowly active metals. Now, refining of metal. Once the metals are extracted, they are not ready to be sold in the market. Why? Because these metals also have so many impurities in it, and those impurities are to be removed before they are sold in the market. Now, to understand this, let us try to see how copper metal is purified or refined. That is refining of metal. So, in this process of refining of metal, a block of impure copper that you have obtained after the metallurgical process is to be taken as an anode, that is a positive electrode. And you must have at the same time some pure copper, and this pure copper you will have to use as a cathode. Remember, impure copper is to be used as anode, and the pure copper is to be used as a cathode. You need to use an electrolyte, and this electrolyte is copper sulfate but acidified with sulfuric acid. Means sulfuric acid is added to this copper sulfate to make it acidified. And then if we perform the electrolysis, then what will happen? The copper sulfate, which is present in the electrolyte CuSO4, it will break down to copper positive ion and sulfate negative ion. You can see those breakdown process has been shown. This is sulfate double negative ions and copper double positive ions will be produced as a result of electrolysis of copper sulfate that has been used in the electrolyte. Now, this copper positive ion from the electrolyte, from the solution, that is this copper positive ions, will be attracted by the anode, because it is, cathode, it is negatively charged. Remember, what was cathode? Cathode was made up of pure copper. So, where already there is pure copper, into that this copper positive ions will move. Remember, along with these copper positive ions, if there were any impurities, they are not charged, and therefore they will not be attracted by the cathode. So, all the impurities will be left behind in the solution, and only the pure form of copper positive ions will move to the cathode. And after reaching the cathode, they will get reduced and will deposit over the cathode as a pure metal. In this way, gradually what will happen, if time goes on, the impure copper from the anode will start getting deposited as pure copper in the cathode, and all the impurities will be left behind the anode inside the container as anode mud. To understand this, let us see this diagram, and it will help you understand how refining of copper is done. You can see this is the electrolytic cell. And here we are using, this is a cathode made up of pure copper, and this is anode made up of impure copper, it is written. And inside this container we are using this blue colored solution, which is actually acidified copper sulfate solution. When electric current is passed, this copper sulfate present here will get decomposed into copper positive ion and sulfate negative ion. Copper positive ion from here will get attracted to the cathode, because it is positively charged, and they will be attracted by cathode, being this is negatively charged. And as a result, what will happen? The pure form of copper will get deposited in the cathode. So in the solution, there will be now scarcity of copper, and to fill up, or to fill up this scarcity, from the anode, impure copper will come down to the solution, and from there again in the pure form it will get started depositing in the cathode. This is how all the impure copper of the anode will be purified in the cathode by reduction process. So this is how by using electrolysis we can purify a metal. Like for example, copper is purified by electrolysis, and so we call it as electrolytic refining. After this, let's come back to corrosion of metals. Now, what is corrosion? It is actually the degradation of any material, especially metals, due to the reactions with its environment. Now, what is there in environment? In environment, there can be oxygen, there can be water vapor, there can be acids, there can be bases, there can be so many other reagents. When those reagents will start reacting with a piece of metal, the metal will start corroding. Metal will form different compounds. As a result, what will happen? The metal is damaged. The metallic actual chemical properties of the metal will be lost and they will form different compounds. This process is called as corrosion. So mostly when metals corrode, they form rust, and we also call it as rusting of metal. Now example, when iron undergoes corrosion, then we can see over iron a dark brown layer is formed. This dark brown layer we call it in English as rust. Similarly, you can see silver metal. It is a noble metal, but even the silver metal, when get exposed in contact with sulfur, or that is you can say it got exposed to other chemicals, then what will, if it's silver is combining with, you can see, if that example we are getting here, second part, you can see when silver metal comes in contact with sulfur present in the air, then what will happen? A black layer will form on the silver metal, and this black layer is formed actually because of silver is reacting with sulfur or so many sulfur compound, and so silver has not remained as silver but perhaps started forming so many silver compounds, and these silver compounds will remain as a layer over the silver metal. This is how the property, chemical property of silver will be lost, and this is how you can see in these two examples, iron and silver, even copper will be corroded. So this is we call as corrosion of metal, or simply we call it as rusting. You have learned a lot of things about rusting in your class 8 standard. Now let us see how can we prevent corrosion. Corrosion is to be prevented, otherwise the metallic property will be lost. So it is prevented how? By cutting the supply of air or water vapor or the reagents with the metal, so that these reagents cannot reach the metal, and if you can stop those reagents coming in contact with the metals, so definitely metals will be prevented from rusting. But the question, how can we do this? We can do it by a number of processes. Number one, that is given, corrosion can be prevented. Corrosion of metals can be prevented by giving a coating of anything which will cut the supply of air, water and different reagents into the metal. Second process, coating the metal with layer of paint or oil or greasing the metal also will save the metal from corrosion. If we see the coating of corrosive metals with some non-corrosive metals, for example, copper can undergo corrosion. So over copper, if we can apply a layer of gold, definitely it will cut the supply of air to the direct contact of copper. As we know, gold is a noble metal. It will never react with any reagents. So gold will prevent the supply of those reagents to come in contact with copper, and this is how copper metal can be prevented from rusting or corrosion. So this is how a non-reactive metal, a noble metal, is to be applied as a layer over the corrosive metal, and we call this process as plating. And this plating is done by electric current, so we also call it as electroplating. Now this electroplating can be done by several ways. Number one, we have already discussed, that is how gold can be applied as a layer over copper. Similarly, another process is given as galvanization. You can see it is galvanization. It is the process of applying a layer of zinc over a metal. and then zinc will prevent the inner metal from undergoing corrosion. And the next is tinning. It is also a process of applying a layer of tin over a metal so that the inner metal can be prevented from corrosion. So galvanization, tinning and electroplating are certain examples. Now alloy. What is an alloy? An alloy is a homogeneous mixture of two or more metals. However, along with metals, sometimes in an alloy, some non-metals may also be present. Now, if some non-metals are present, then what will be those non-metals? Those non-metals basically which may be found along with an alloy are boron. They may be carbon, they may be silicon, or sometimes they may be even sulfur, but mostly carbon. But apart from metal and metal, two or more metals, sometimes two or sometimes three, sometimes four metals, if they combine together to form a homogeneous mixture, then mixture is an alloy. But sometimes along with the metals, the non-metals like boron, silicon, carbon and sulfur may also be found as non-metallic part of an alloy. Now what is an alloy? Alloy is always harder than the original metal, tougher than the original metal, and at the same time it is non-corrosive. Therefore, most of the metals are converted to their alloy form so that metals can be given more durability. That is why alloys are important. You can see here a list I have given for you, and this list will help you to know the names of some alloys on the left hand side, like brass is an alloy of copper and zinc. What is its use? It is used in making utensils, pipes, the radiators, etc. Second, you can see bronze. It is another metal. It is also made up of copper, but along with copper there is tin. And this bronze is used in making coins, currency coins. It is also used in making ornaments, utensils and the statues. Similarly, you can see the other metals like stainless steel. Then you can see magnesium is there, duralumin is there, German silver, then gunmetal and soldier material. In the middle you will get the composition, what are the different compositions of those metals and alloys, and on the right hand side you can see what are their uses. This is very important. If possible, please write it down in your copy. Finally, we are coming to know that an alloy, it is one of the metal in an alloy. If any one metal is mercury, then these alloys are called as amalgam. So that is to say that whenever in an alloy mercury is present, then these alloys are always called as amalgam. Now gold, let us take an example. So you have heard about gold, and people are talking about pure gold and impure gold. Now what question is, what is the purity of gold? Purity of gold in India, we always define them in the form of karat. And what is it? 24 karat gold. It is the purest form of gold, but it is very soft. It is so soft that from this 24 karat gold, you cannot make any ornaments. And even if some ornaments are made, these ornaments will break down very easily. Why? Because it is pure gold. And pure metals are always softer than their alloys. So what is done? Gold is mixed with copper. And when gold and copper are mixed together, an alloy is formed, and as a result, this gold alloy becomes very tough, hard, and now they are very good for making ornaments. So this is how gold is actually made an alloy, means impurity. The gold is converted to impure state. And this impurity is necessary to make ornaments. Generally, what is done in India, 22 karat gold is used for making ornaments. Now what is 22 karat gold? It means 22 parts of gold will be added to 2 more parts of copper. So it is 22 karat gold is there, and along with that 2 karat copper is there, and it will make it to 24. But 24 means pure gold, and 22 karat gold means it is actually an alloy of gold and copper. 22 karat means there are 22 parts of gold is there, but remaining 2 part is copper. So in that way, if the purity decreases, it may be 20 karat gold or maybe 18 karat gold. That means gold part is decreasing and copper part is increasing, means impurity is increasing. So this is what we have tried to understand today about the occurrence of metal. In this lesson today we have learned metals occur in the nature either in the free state or in the combined state. If they are in the free state, there is no problem, but if they are in the combined state in the form of minerals or ores, they are to be extracted, and this extraction is done on the basis of their reactivity. Highly reactive metals are extracted by electrolysis method. Moderately active metals are reduced by carbon reduction process, and less active metals can be reduced by simple heating. We have taken examples of those extraction processes. Then we came to know how metals can be purified, and we have taken example of copper, that is how by electrolytic refining copper metals can be purified. Finally, we have come to know about alloys and corrosions. What is corrosion, how corrosions can be prevented, and finally alloy, different types of alloys, their chemical composition, some examples. Thank you very much. So that is the end of this chapter number 3. If online classes continues, then we will definitely start a new chapter next time. Thank you very much.